All right, let's dive right into this explainer. You know, it's pretty wild to think about how human beings survived scorching summer heat long before the invention of air conditioning. I mean, societies didn't just survive, they thrived in some seriously brutal climates without the luxury of a thermostat. And the answers to how they did it? Well, they lie right in the architecture of the past. These days, we rely so much on expensive, energy-guzzling mechanical cooling. And let's be honest, those loud, dripping AC units aren't exactly beautiful to look at. But what if I told you the secret to staying comfortable is actually built right into the anatomical design of traditional architecture? Ancient builders didn't just throw up some walls. They engineered living, breathing structures designed specifically to outsmart their local climates.
Section 1. The Shield. Fighting invisible forces.
So to understand how a building actually stays cool passively, we first have to understand the enemy: heat. The golden rule of thermodynamics we got to remember for this explainer is super simple. Heat is always going to try to move from a hotter region to a colder one. In the summer, that means the sweltering outdoor heat is constantly, relentlessly trying to push its way into your relatively cooler living room. Basically, heat invades our living spaces in three primary ways. First, there's conduction, which is heat moving directly through solid walls and roofs. Second is convection, happening when moving warm air leaks into the building. And third is radiation, which is the sheer, raw power of solar electromagnetic waves piercing right through transparent glass.
Take conduction, for example. It's exactly like leaving a metal spoon in a hot cup of tea. The heat just transfers through physical contact, right? That spoon gets piping hot all the way up the handle. Well, your walls and roofs act exactly like that spoon if they aren't properly protected.
To fight off this physical transfer of heat, builders use thermal insulation as their very first line of defense. Think of it as a shield made of materials with low thermal conductivity, like fiberglass or, traditionally, really thick earthen walls. They physically stop the heat from getting in during the summer and keep it from escaping in the winter.
This creates a brilliant two-way barrier. It literally deflects the harsh solar radiation away during the hot summer months while simultaneously trapping all that cozy warmth inside during the freezing winter. It's a complete two-for-one climate solution.
Moving on to Section 2, the stance, designing for the sun.
You know, just placing a building the right way on a plot of land can neutralize heat before it ever has a chance to hit the walls. Traditional planning recommends a very specific geometry, placing the long walls facing north and south and the short walls facing east and west. Why? Because it drastically minimizes the surface area exposed to that intense morning and afternoon sun. It automatically keeps the interior cooler without doing anything else.
But of course, orientation alone won't entirely cut it. Planners also use strategic passive shading tactics. They'll place verandas and balconies on the east and west to act as deep, shaded buffer zones. On the south face, they use horizontal projecting sunbreakers, often traditionally called jajas, or extending roof eaves to literally intercept solar heat before it ever touches the glass.
When you combine those wide roof overhangs with strategically placed deciduous trees, you get this incredibly dynamic shading system. I mean, think about it. The tree provides crucial, dense, natural shade in the summer when it's full of leaves. But in the winter, when the leaves fall off, it lets that lower-angled winter sunlight pass right through to naturally warm the home. It is perfectly synced with the seasons.
Oh, and we absolutely can't forget the ground outside. The microclimate right around the building matters immensely. Untreated ground can radiate intense heat straight upward. It can take mildly warm, say 32 degrees Celsius air, and turn it into an absolutely unbearable 45-degree microclimate right outside your window. No thanks. But treated ground, stuff like grass and vegetation, can physically cool the incoming breeze through shade and moisture, keeping it totally refreshing.
All right, Section 3, the lungs, how buildings breathe. So you've shielded your building and faced it away from the sun. Now what? You've got to give the structure lungs. It has to inhale fresh air and exhale the stale heat. This brings us to natural ventilation. It's really the art of harnessing nature's own invisible forces, like wind pressure and temperature differences, to flush out stale hot air and pull in fresh breezes. And doing all of that without a single mechanical fan.
There are basically three main ways to get this passive airflow going. First, you have single-sided ventilation, which is decent but kind of limited. Then there's cross-ventilation, where air flows in one window and straight out the opposite side. And finally, you have stack ventilation, pulling air upward and out through the roof.
But to make sure these architectural lungs actually work, designers follow some pretty strict rules. Doors and windows have to be placed to maximize inflow. The building itself needs sufficient height to give the air room to actually move around. And this is absolutely crucial. Those inlet pathways can never, ever be blocked by dense, low trees outside or internal partition walls inside. The air needs a completely clear path to do its job.
Now, one of the most brilliant methods here is the stack effect. It's basically a masterclass in convection. It uses warm air's natural tendency to become lighter and rise, acting as this invisible, silent engine to drive continuous airflow right through a building. Picture how the wind passing over a building's roof creates a low-pressure suction zone. This vacuum physically yanks the lighter, warmer indoor air up and out of the high vents. And as that warm air escapes, it creates negative pressure inside, which then pulls the cool, dense, fresh air in through the windows down at ground level. It's a completely automatic, perpetual cooling loop powered entirely by physics. How cool is that?
Which brings us to Section 4, Timeless Passive Cooling, the blueprint for our future.
By elegantly weaving together the shield of thermal insulation, the stance of sun-conscious orientation, and the lungs of natural ventilation, traditional builders mastered their local climates entirely passively. They worked with the environment, not against it. As our source material highlights perfectly, true architectural achievement isn't just hooking up a bigger, louder AC unit. True achievement is intelligently utilizing a building's form, its orientation, and the forces of nature to hit perfect thermal comfort without ever flipping a switch.
Which leaves us with a pretty compelling question to wrap up this explainer. As we look around at our modern, energy-hungry world full of these sealed glass boxes, we have to ask ourselves, are the spaces we live and work in actually operating in harmony with nature? Or are they just fighting an incredibly expensive and ultimately losing battle against it? Definitely something to think about the next time you feel a cool breeze on a hot summer day. Thanks for joining me on this explainer.